So this is part 2 of the number 5 mixed review. All right, so first of all, we have to look at 9 pi. And 9 pi is not on the unit circle. So what you have to do is make it be on the unit circle by subtracting 2 from 9 until you get a number that is on the unit circle. When you subtract 9 minus 2 enough times, you'll get 1. And 1 pi is on the unit circle. Okay, so now what we do is we take our unit circle and look for the sine, cosine, and tangent of pi on the unit circle. Well, sine is going to be 0. That's the y value. The cosine of x is going to be -1. And the tangent is going to be 0 divided by 1, which is undefined. Actually, no, sorry. 0 divided by -1 is 0, actually. All right. For part B, we have -7 pi over 4. Well, that's too small to be on the unit circle. The unit circle is between 0 and 2 pi, and -7 pi over 4 is less than 0. So we have to add 2 multiple times. Or actually, I think it's just once. If you add 2 once, it might be twice, I can't remember. Anyway, you'll get a radian of pi over 4. You'll get 1/4. Okay? From there, you look at the unit circle to find the sine, cosine, and tangent. The sine, the y value, oops, sorry. The y value is going to be √2 over 2. The cosine, the x value is going to be √2 over 2 again. And tangent is sine divided by cosine, which is just going to be 1. All right. For 13 pi over 6, part C, 13 over 6 is too big, so we're going to subtract 2. And it could be multiple times. I think it's just once. All right. That's going to give you pi over 6. So 1/6. Again, you should be using your calculator for this. Once you get a decimal, convert it into a fraction using the math enter button. And you should get your fraction so you understand which one it is. For pi over 6 of sine, it's the y value. You got 1/2. For cosine, it's the x value. It's √3 over 2. And for tangent, well, that's a little more difficult. So we're going to delve into this one. We've done this before, but just in case you don't remember, you have to divide 1/2 by √3 over 2. Since this is a complex fraction, you're going to multiply by the reciprocal of the denominator. So this all cancels out. The 2's cancel out. And you're left with 1 over √3. Well, you're not allowed to leave √3 on the denominator. You can't leave radicals in your denominator of your fraction. So you're going to multiply by square root of 3 to the top. Okay, so the square root of 3 times the square root of 3 gives you just 3. And then 1 times the square root of 3 is just the square root of 3. So you get square root of 3 over 3 is your answer. Okay. For 14, all the 14s, you're going to do the same kind of thing. You're going to find the point values on the unit circle of the specific radians and their trig functions. All right, so for sine of pi over 3, it's the y value, which is going to be √3 over 2. And for cosine of 23 pi over 6, well, that's too big to be on the unit circle, so you're going to do kind of what we did in the last problem, which is subtract by 2 until you get a number between 0 and 2 pi. If you subtract 23 over 6 by 2, eventually you'll end up with 11 pi over 6. So now you need to find the cosine of 11 pi over 6, which again is just like the other part, is √3 over 2. Now you're multiplying these two things. So the square root of 3 times the square root of 3 is just 3. Square root of 3 times square root of 3 is the square root of 9, and the square root of 9 is just 3. And the denominator is 2 times 2 is 4. And that's it. For part B, tangent of 5 pi over 4. Well, you have √2 over 2 divided by √2 over 2, which you're going to just get 1. All right. And then for sine of pi over 2, that's also going to be 1. All right. So 1 times 1 is just 1. All right. Part C. Excuse me. 7 pi over 6. I want to find the cosine of that. That's going to give you negative √3 over 2 for the x term. All right. For 11 pi over 3, okay, that's again too big for the unit circle, so you're going to have to subtract 2 from 11 pi over 3, you'll end up with 5 pi over 3. And you'll get 1/2 when looking at the unit circle. So negative root 3 times 1 is going to give you negative root 3. And 2 times 2 will give you 4. Oh, whoa. Sorry. 2 times 2 will give you 4. All right, lastly, we have 4 graphs. All right, so just as a quick aside here, I'll put it right in the middle. Okay. So step 1, all right, we have period intervals. Step 2, you're going to be doing horizontal shift. Step 3, first point. Step 4, use amplitude to find the next points. So if we do that, follow that list, we have 2x equals 2 pi. Divide both sides by 2, and x will equal pi. So that is your period. All right. I'll make this a little bigger to fit all this in. So we have pi as our period. Half of that is pi over 2. Half of that is pi over 4. And 3 times pi over 4 is 3 pi over 4. Okay. Now there is no horizontal shift in this, so we can skip section or step 2. Step 3, go to the first point. So we have sine. We have 3 times 0 minus 1. So 3 times 0 is 0, and minus 1 starts our first point right there. Okay, now we use our amplitude to find the rest of the points. So we're going to go up by 3, 1, 2, 3. Go down by 3, down by 3, and up by 3. And there is our graph. All right, part 16. So this is secant, so we're going to graph a cosine graph first to figure out where the secant graph is going to go. So step number 1, find the period intervals. Well, the x value is not being multiplied or divided by anything, so the period is still going to be 2 pi. Half of that is pi. Half of that is pi over 2. And then 3 pi over 2 is the third one. Apparently people are moving furniture above me. All right, horizontal shift. This time it says minus pi, which means we're going to go 2 intervals because pi is 2 intervals from the origin. 2 intervals to the right because it's plus. You're going to go the opposite direction. So we're going to add 2 more intervals to our period. So we're going to have 5 pi over 2 and then 3 pi. All right, the first point. So cosine starts at 1 times 2 minus 1. So 2 times 1 minus 1 is going to be 1. All right. Then we're going to use the amplitude to find the rest of the points. So you're going to go down 2, up 2, and up 2. Now remember, we're graphing secant, not cosine. So this cosine graph is going to be a dashed line. All right. And then all the points that would normally go through the x-axis, not the peaks or the valleys, but the other points, are going to be asymptotes. I'll change colors for the actual graph. The graph's going to be parabola-type shapes on the peak and the valley. And there you go. That is the secant graph. Two more graphs. Okay, so now we have a tangent graph. Again, the first step is the period, so we have 2x equals, now remember, tangent graphs only have a period of pi, so we divide both sides by 2. Your period is going to be pi over 2. Now, again, with tangent graphs, the period is cut in half by the y-axis, so half the period is going to go on the right-hand side, so we're going to do half of it here. So half of pi over 2 is pi over 4, and pi over 8. The other half is going to be on the other side, so we have negative pi over 4, and negative pi over 8. All right, the asymptotes for tangent go on either side. All right, it says plus 1, and the tangent graph has up to the right and down to the left. And there's your graph. Last graph, just a cosine graph. All right, again, we do the period first. So we have 8x equals 2 pi. Divide both sides by 8. And x will equal pi over 4. All right, so we start off with pi over 4. Divide that by 2. You're going to get pi over 8. Divide by 2 again. You're going to get pi over 16. And then 3 times that is 3 pi over 16. Okay, first point. Oh, sorry, horizontal shift is the next step, but there is no horizontal shift. So then we go to the first point. Cosine starts at 1. So 3 times 1 is going to be at 3. Then you use the amplitude to go down 3, up 3, and up 3. And here's your cosine graph. All right, and that is it. So that is the key for the mixed review. If you're having any questions, please reach out to me and let me know, and I'll